Alright guys, today we're going to look at lesson 8.1, exponential growth and decay functions. You did study exponential growth and decay a little bit in Algebra 1, but we're going to start with the basics. So let's analyze exponential growth and decay. An exponential function is a function of the form f of x equals b to the x power, where b is a positive constant other than 1 and the exponent x is a variable. The function represents exponential growth when b is greater than 1 and exponential decay when b is between 0 and 1. Alright, so you can see anytime you have exponential function, the variable is the exponent. So that's why it's exponential. Okay? Alright, so consider the exponential functions f of x equals 2 to the x power and g of x equals 1/2 to the x power. As the value of x increases, f of x, all right, so think about this. 2 to the first power is 2. 2 squared is 4. 2 to the third power is 8. So this one's going to increase. As the value of x increases, the value of g of x, so this is 1/2. So 1/2 squared is 1/4. 1/2 to the third power is 1/8. And so that one is getting smaller, so it's going to decrease. All right, it says complete the table of values for f of x and g of x. All right, so these are filled in, and we've got f of x equals 2 to the x power. And again, we're just substituting these values in for x. So 2 to the 0 power, anything to the 0 power, property of exponents, is 1. 2 to the first power is 2. 2 squared is 4. And 2 to the third power is 8. All right, now you can see up here, g of x 1/2 to the negative 3 power is 8. Now why is that? Because when you have a negative 3 power, you have to flip this and make it positive. So the 1/2 would become a 2 to the third power. If you change that, that's why it becomes an 8. So then you've got 2 squared is 4. So you can see that these are kind of the opposite of these here. So this one would be 2. Again, if it's a negative 1 exponent, to make it positive 1, you flip this. It becomes 2 to the first. 2 to the first is 2. These are filled in 2. So 1/2 squared. That means you square the top and the bottom. So it'd be 1/4. And then to the third power, 1 to the third is 1 over 2 to the third is 8. And you can see these are the inverses, or these go in reverse of this. And that's because that's a 2 and that's a 1/2. All right, so looking at the graph, f of x is 2 to the x power. All right, so 2 to the x power is going to look like this. And g to the x is exponential decay. It's going to look like this. So remember, if your b is greater than 1, it's exponential growth. And if it's between 0 and 1, it's exponential decay. So that's shown here, where this is a 2, that's exponential growth, and this is 1/2, that's exponential decay. All right, so let's use the graph to identify some key characteristics of each function. All right, the domain of f and g. We can see that these go with arrows in both direction, left and right, forever. So the domain is going to be all real numbers. Remember, your domain is your x values. All right, the range. The range is everything above 0. All right, so the range is your y values. So we're going to have y greater than or equal to 0. And again, that's for both of them, because you can see this one, again, the graph is everything above 0. All right, in behavior. All right, as x goes positive, y goes positive. As x goes negative, y approaches 0. Okay, so it doesn't go down forever. Now it's going closer and closer to 0. So let's see. As x approaches infinity, y approaches infinity. As x approaches negative infinity, y goes to 0. Okay, so that's f of x. And then g of x is the opposite. You can see that as x goes negative, y goes positive. As x goes positive, y approaches 0. So this one's going to be as x goes positive, all right, so that's just a little bit different. You can see that these are the same. These are a little bit different just because this one approaches 0 on the left and this one approaches 0 on the right, which means this is your positive x's and this one's on your negative x's. So that's the only difference there. All right, horizontal isotope. All right, isotope is the line that your graph approaches without touching it. So that would be y equals 0. And that's for both graphs. That may be a definition that you need to put in your notes. Horizontal isotope. I'm not sure if we've covered that in a previous class or not. It was not in the vocabulary, but that would not be a bad term to make sure you know what that is. All right, your y-intercept for f of x, you can see that is 0, 1. And g of x is 0, 1. So they also have the same intercept. Make sure you choose 0, 1 as your y is 1, not your x. So they put that there to be a little bit tricky. All right, so you can see all of these are the same. The only difference was the in behavior. So they have a lot of similar characteristics. Describe the similarities and differences of the graph. Okay, that's what we just did. Similarities, they have same domain and range. They have the same horizontal isotope. They have the same y-intercept. And their in behavior is different just in which side of the graph it approaches 0 and which side goes towards infinity. All right, using the key characteristics for part C, what generalizations can you make about the general exponential function f of x equals b to the x, where b is any positive real number other than 1? All right, so the function blank exponentially for all b greater than 1. So it's going to grow or increase. And blank between 0 and 1. So it's going to decrease if it's between 0 and 1, because this is exponential growth. This is exponential decay. All right, for the functions, f of x equals 2x, g of x equals x squared, and h of x equals 2 to the x power. So this is linear, this is quadratic, and this is exponential. It says make a table of values for x from 0 to 5 and graph the three functions on the same coordinate plane. Describe what you observe as the values of x increase. All right, just because of time, let's graph these quickly on the calculator. So let's graph 2x, and then we're going to graph x squared. And then we're going to graph 2 raised to the x power. All right, so the first line to be graphed will be the line. 2x is linear, it's a line. Quadratic is a U-shaped graph, and exponential is the graph that we just learned that has an upward curve. All right, so what do you see as the x's increase? You can see that the linear one goes straight. It's going to be constant because that's what it is, a constant function. Quadratic curves up at the, not a fast rate, but then exponential is going to grow exponentially. So the exponential curve is going to get steeper and steeper and steeper as it goes. And if we look at the window, let's change our y maximum to 20 and just see if you can see where those separate. There's your linear. quadratic, and there's your exponential. Okay, so let's look at the table of values and see what it says. All right, so from 0 to 5, that's what it says. Make a table of values from 0 to 5 and graph the three functions on the same coordinate. Describe what you observe as the values of x increase. Okay. What's only showing us x or y1 and y2 right now. So this is just showing us the linear and the quadratic, so it doesn't show us all the way. There it is. There's the third one. Okay, so the y3 is the exponential. So you can see the quadratic and the exponential as x goes from 1 to 5. You can see that the exponential at 4, they're the same. At 3 and 4, they're the same, but once you get to 5, the exponential starts getting steeper much quicker. All right, find and compare the rate of change for f of x and the rate of change of g of x and h of x. All right, so take two values for f, g, and h. Remember, rate of change is difference in y's over difference of x's, and see what you get. What you should get is that the exponential function is going to grow much faster. The rate of change is going to be more drastic. So rate of change here will be constant. Rate of change here is going to be faster than this. And the rate of change here will be the fastest. So it would be the greatest rate of change for h of x. All right, if you have any questions with task 1, please let me know.